Alright guys, so in lesson 10.2 we're just going to be looking at some basic probability here. So basically here, probability is a measure of how likely an event can occur. So the probability of an event occurring is the ratio of the number of favorable outcomes over the number of possible outcomes. So the number of desired goes on top and the number of possible outcomes on bottom. So if an event is impossible, the probability is going to be 0. If an event is certain to occur, meaning it's going to happen, the probability is going to be 1. So probability is always measured from 0 to 1. So let's go and look at these examples real quick. So if each of the letters in the word father is written on a card and placed in a basket, what is the probability of choosing a vowel from the basket? So remember, the number of desired outcomes goes on top and the number of possible outcomes go on bottom. So right here, there are 5 letters in the word father. So obviously 5 is going to go on bottom. And then we want vowels. So vowels are A, E, I, O, U. So A and E are the only vowels in father. So 2 over 5 is going to be your probability, which 2 over 5 is going to represent 40% chance of you grabbing a vowel out of there whenever you reach in there and grab it. Okay? So now number 2, a pen holder on the top of a desk contains 2 red pens, 3 blue pens, and 1 black pen. What is the probability of randomly choosing a blue pen from the holder? So right here, we're going to do the same thing again. Number of desired on top and the number of possible on bottom. So right now, we have 2 red pens, 3 blue pens, and 1 black. So that's going to be 6 total pens. So that's going to go on bottom. And then we want to see how we grab a blue pen. So there are 3 blue pens. So we want 3 blue pens. So that goes on top. So 3 over 6 is going to be 50% because it's going to represent 1/2. So there's a 50% chance that if you were to reach in and grab one of these pens, you would grab a blue pen. So on those previous examples, these were known as simple events. So whenever you take simple events and you put them all together, this is known as compound. You're compounding and putting them together. So compound probability is an event made up of a sequence of simple events. So if you put a lot of simple events together, that's going to be known as compound probability. So inside compound probability, there's 2 types of it. There's something called dependent and independent. So in compound probability, if the outcome of one event affects the possible outcomes for another event, then the events are called dependent. So here the events depend on one another. So for instance, if you reached in and grabbed a red pen out of a bag, but you never replaced it, taking that 1 pen out on the first try is going to affect the second one. So that second one is dependent on the first one. So in compound probability, if the outcome of the first event does not affect the possible outcomes for the second event, then the events are called independent. It means they're separate from each other. They don't affect each other. So for instance, if I was to roll just a regular die, anytime I roll that die, the previous one is never going to affect the next one because nothing happens to the die. Nothing's taken out or nothing's changed. So that means it's independent from each other every time I roll that. So on number 3 on the example, it says, suppose you spin a spinner with the numbers 1 through 4 written on it, and then you spin it again. Does the outcome of the first spin affect the likelihood of spinning a 3 on the second spin? Why or why not? So let's think about it. If I was to sit there and I was to spin a spinner, is anything going to change on the spinner each time I spin it? No, it's not. So there is not going to be any change from it. So it does not affect it. So this is going to be known as a independent. Because every time I spin that spinner, it's not going to affect the previous one. So on example number 4, in example 2, you found the probability of drawing a blue pen from a pen holder that had 2 red pens, 3 blue pens, and 1 black. If after you first draw, you replace the blue pen and drew again, what is the probability that both draws will be a blue pen? So this is going to be compound probability. So let's go and think about this. So after your first draw, if I replace the blue pen and drew again, what's the probability that both will be blue pens? So let's think. The first time I draw, there's 3 blue pens out of 6 total. Okay? So that's the first time I draw. If I draw again and I put it back in. Then the second time I draw is going to be 3 over 6 again. So the probability of me drawing a blue pen on both draws, 3 out of 6, I'm going to multiply these together. So 3 times 3 is 9. 6 times 6 is going to be 36. So there is a 9 out of 36 chance, or if I did 9 divided by 36 in the calculator, so there is a 25% chance that this is going to occur. So in compound probability, all I have to do is multiply the two together, and that's going to give me the percentage of that happening. Okay? So now on B, if after you first draw, you did not replace the pin, but you drew again, what is the probability that the first pin drawn is blue and the second pin drawn is going to be blue? So let's go and think about this. So again, the first thing I want to draw is a blue pin. So there are 3 blue pins out of 6. So 3 out of 6 is going to be my first draw. And so we want to end up getting a blue pin, so we want to figure out that probability. So if I reached in and took out a blue pin, then there would be 2 blue pins left, so I wouldn't redraw that. So then there would be 2 blue pins left out of now 5 pins because I took 1 out of both of those. So then, in order to find compound probability, is I would multiply these two together. So 3 times 2 is going to be 6. And then 6 times 5 is going to be 30. And then 6 over 30, if I type this in the calculator, 6 divided by 30 as a decimal is going to be 2 zeros, so 20%. So there's a 20% chance that I would end up drawing 2 blue pins. Okay, and lastly, on the back page, we're going to talk about something called conditional probability. So conditional probability contains a condition that limits a sample space for an event. So specifically, if I'm looking at something, it's going to put a condition or put a limit on what I'm looking at. So you can write a conditional probability using the notation, the probability of B happening given that A has already happened. So that's what this part represents here. So inside example number 5, the only way to explain this is by looking at an example really. So the table shows the results of a class survey. We need to find the probability of did a chore given that that person is already a male. So we need to find the probability that someone did a chore given that they are a male. So that means we need to look right here. Male is our condition. So that means we are only in this problem going to look at the male column. Okay? And we want to figure out if they did a chore. So right now, we're going to add up all the males, and that's going to be my total. So 7 and 8 equals 15. And then 7 out of those 15 are going to be a yes, they did chores. So there is a 7 out of 15 chance that you're going to get somebody that did their chores. So 7 out of 15 is a decimal. There's a 46% chance that you're going to get a male that did his chores. Okay? So now look at number 6. In the table above, we need to find the probability of somebody that did not do a chore that is a given that the person is a female. So that means in this example, we are only going to look at the females. Only going to look at the female column because female is our given here. So right now, 7 and 6 is going to equal 13. So that means inside here, there are only 13 females. And 6 of those females did not do a chore. No, they did not. So 6 over 13, if I was to randomly choose, that means that 46% of those is also going to be a did not do a chore. So remember, whenever you're looking at conditional, the second part here is going to give you a condition. It's already given, so this is going to happen whenever you're already given this.